Have you ever looked at just a massive data lake? These huge raw storage repositories, petabytes deep, just seemingly endless amounts of enterprise data, and wondered, okay, how do we actually turn this into real, tangible business value using AI? It's a really common challenge, isn't it? We see companies pouring money into data and AI. I mean, the promise is incredible, but there's often this frustratingly wide gap between just having the data and truly using it effectively.
That's exactly right. And this is where the crucial piece comes in. You need the right engine. Most data lakes, by themselves are kind of passive. They hold all this potential, but they need something to activate them, to really wake them up. So today we're doing a deep dive into how Apache Spark doesn't just process data, it truly activates it. It becomes this foundational layer for building scalable, high-impact AI and machine learning programs. Our mission here is to help you understand what you really need to know, whether you're, say, an executive trying to drive innovation, or maybe a data professional actually building these systems just to stay ahead in this landscape that's evolving so incredibly fast.
Okay, let's unpack that then. At its core, what exactly is Apache Spark? I mean, the source calls it a unified analytics engine. Can you maybe paint a clearer picture for us? Something easier to grasp.
Absolutely. Think of your data lake like a giant warehouse. It's packed with all sorts of raw materials, timber, steel, electronic bits. It's all there, but it's raw. It's maybe disorganized, not really useful yet. Spark then is like the sophisticated high-tech factory machinery inside that warehouse. It takes those raw materials, that raw data, and transforms it into usable parts or, in our world, powerful AI models and actual insights you can act on. It's really the engine bringing static data to life, making it valuable. And what's really powerful, I think, is Spark's versatility. It works across the entire AML pipeline. It's great right from the beginning, getting data in, handling ingestion, then doing complex transformations, even that really tricky feature engineering part, which is, taking raw data and shaping it so models can actually understand and learn from it. Plus, and this is big, it integrates directly, pretty seamlessly with the major machine learning libraries out there. That's a huge plus for data scientists using different tools.
Right, and the source also really emphasizes Spark's performance. Words like scalable, distributed, lightning fast, capable of crunching petabytes of all kinds of data, structured, semi-structured, totally unstructured. Now, petabytes. That's just a mind-boggling amount of data for most people. But beyond just the raw speed, what are let's say, the hidden costs or the typical roadblocks that Spark helps organizations get past? It's not just speed for speed's sake, right?
Oh, absolutely not. Speed is great, but the strategic value that comes from smashing those bottlenecks you don't always see. Like, imagine a company where data systems are all fragmented. Data teams are drowning in manual data prep, maybe. Or maybe they're forced to shrink down their data sets, downsample them, losing crucial details just so they can process it on one machine. Spark cuts right through that. It lets data scientists and engineers actually collaborate on the same robust platform. And that drastically cuts down those painful handoffs between teams. It reduces the friction that just, well, plagues AI development so often. And the result of having this kind of integrated high performance setup, it's genuinely transformative. You get faster development cycles, you get the ability to deploy models in real time, like as events are actually happening, and often really significant savings on cloud costs. Because, Spark's pretty smart about using resources and make sure you're only paying for the compute you actually need when you need it, much more efficient. It really is about moving from, say, endless experiments or just building dashboards to precise, fast execution that delivers real business outcomes, measurable ones. And that for a lot of companies, well, it can fundamentally change their position in the market, turns data from a cost center into a real competitive edge.
Okay, let's bring it down to earth a bit, because that's where the value really clicks, right? How does all this power translate into actual practical applications for different kinds of companies, different roles? Give us some concrete examples.
Sure, sure. Let's think about a financial services executive, right? If your goal is real-time fraud detection, flagging dodgy transactions instantly across millions happening every day, Spark's streaming machine learning capabilities, that's exactly what you need. It crunches those continuous data streams, applies complex models on the fly, stops losses now. Or picture a retail leader focused on hyper-personalizing the customer journey. Website recommendations, tailored emails. Spark's ability to handle really big, deep learning models, huge recommendation systems that makes that kind of personalization possible across millions of customers. Drives engagement, drives sales at scale.
Okay, and what about for the data professionals listening? The folks, in the trenches every day. How does Spark specifically empower the data engineers, the data scientists? Make their jobs, well, easier and more impactful?
Yeah, good question. So, for data engineers, Spark lets them build incredibly robust, resilient ETL pipelines, extract, transform, load. They can clean, combine, prepare data from all sorts of sources really fast. They become the architects of that solid data foundation. It also helps them manage schema evolution gracefully. That's when your data structure changes over time, add a new field, whatever. Spark adapts without everything breaking. Plus, they can orchestrate complex Spark jobs with tools everyone uses, like Airflow or Kubernetes. These are like the conductors for data workflows, making sure complex stuff runs automatically and scales efficiently. Cloud, on-prem, wherever. And then for the data scientists, Spark just unlocks this ability to train models directly on massive data sets, no more compromises. Spark MLOps, for example, it's got a whole suite of machine learning algorithms optimized for distributed data, makes common tasks super efficient at scale. And the integration with things like PyTorch or TensorFlow, that means scientists aren't locked into one way of doing things. They can use their favorite tools, their existing models, directly on Spark's huge scale. No more frustrating downsampling, no more potentially losing accuracy because you had to shrink the data. And if we connect this to the bigger picture, MLOps, machine learning operations, Spark supports that whole life cycle too. MLOps is really about reliably getting models into production and keeping them there, right? So that means things like data lineage, knowing exactly where your data came from, how it changed, crucial for trust, model versioning, tracking different model versions, rolling back if needed, and automated retraining, keeping models fresh as new data comes in. This comprehensive support means your models aren't just lab experiments, they're trusted, maintained, optimized in the real world, making them useful long term.
That is a lot of power. It really raises an important question, though. Beyond what it does for companies, what does mastering Spark mean for the individual data professional? Someone looking to, advance their career. The source calls it a career accelerator, but is it really that indispensable today? Or are there other tools that can kind of do the same job?
Oh, it absolutely is indispensable and in very real ways. Think about it like this. For a data engineer, being fluent in Spark makes you the backbone of the AML infrastructure. You build the reliable pipelines, manage the complex systems. That's foundational. For a data scientist, it's about taking those brilliant ideas, those prototypes, and scaling them up from something that works on your laptop to something that handles real-world enterprise data. That's huge. And for MLOps engineers, Spark is your go-to tool for automating deployment, monitoring, governing those critical AI models in production, keeping the lights on, basically. And yes, while other tools exist, Spark's flexibility across that entire data lifecycle, from basic cleaning right up to complex deep learning, it makes it pretty uniquely powerful. So long story short, if you're fluent in Spark, your value in the job market just, well, it skyrockets dramatically. Companies are actively, almost desperately looking for people who can bridge that gap between having tons of data and actually making smart data-driven decisions with it. This is where technical skill directly drives strategic impact for the business. It's maybe less an accelerator and more of a career catapult.
So, it sounds like whether you're an executive trying to guide innovation or a data professional actually building these things, our deep dive today really shows Apache Spark is, well, it's much more than just another tool in the toolbox.
Indeed. It really is the ignition switch, isn't it? For turning that dormant data into active intelligence. We've seen how it processes, transforms, and activates data for these critical AI and ML projects, moving companies from just having data to really acting on it fast and at scale.
Right. So until next time, maybe something to think about is this. How might activating your own organization's data lake, using powerful tools like Spark, how might that fundamentally change the kinds of decisions you can make, and maybe even more importantly, the speed at which you make them? Keep turning data into decisions.